Hi, this is Ahed with Logos Learning, and in this video I will discuss double displacement, which is a type of chemical reactions. So a double displacement is a reaction in which two ionic compounds react and exchange their cations. Let's take a look at this general formulation for it. So here we have compound AB, and as you know from before, from my previous videos, whenever you write a compound, you write the metal first. So the metal is usually the cation, and the non-metal second, the anion. Now we have another compound reacting with it, compound CD. This is the cation, the anion. Now, in the course of a double displacement reactions, the cations will get exchanged. So now we're going to put A with D and B with C, or C with B. So they're going to exchange partners. And now we start with two compounds and we end with two compounds. Let's take a look at a more concrete example here. Sodium chloride and silver nitrate react together to form silver chloride plus sodium nitrate. Now you see here that the cation, which are the sodium and the silver, have exchanged partners. And notice here that one of our products is a solid. This is one of the indicators that a reaction did take place. If both products were aqueous, just as the reactants are, then everything, all the ions, will be just floating in solution and nothing would form. If both products are aqueous, this is what we call the case where a reaction did not take place. Now, these reactions, or these types of reactions, always occur in solutions. So if you are mixing two compounds that are dissolved in water together, how can you tell in real life if a product did form, if a reaction did take place and a product did form? Well, the first indicator is the production of a gas, and you can see this visually by bubbles forming. So bubbles will come out of your beaker. So remember here that one of the products has to be a gas. Two types of reactions generally produce gas, and these are the reactions of acids with metal carbonates and the reactions of sulfides with acids. So let's take a look at the first case. We have calcium carbonate plus hydrochloric acid, and that yields calcium chloride plus carbonic acid. Now remember, when you write the products, before you write any product, you have to make sure that you know the valences of these ions, and you use these valences to write the proper formula. Let me show you what I mean. Before I write calcium, I know that calcium is going to go with the chlorine, but before I write CaCl, you have to go to the periodic table and verify and see that Ca is 2 positive and Cl is 1 negative. Now you crisscross the charges, and these charges in the formula become the subscripts of each element. So calcium gets a 1, which we don't have to write because it's implied, and chlorine gets a 2. So this is how we write the formula for calcium chloride. Same deal with H and CO3. H is H plus 1. CO3, hopefully you have a proper periodic table which has all these polyatomic anions on the back. CO3, or carbonate, is 2 negative. You crisscross, becomes H2CO3. Now H2CO3 is an element or a compound that is unstable, and which is going to break down to form water and carbon dioxide gas. So here is the formation of your gas, and this reaction did take place. So yes, there was a reaction here. Let's take a look at the second case where a gas forms. Whenever you react sulfides with acids, so this is hydrochloric acid and zinc sulfide, you will produce hydrogen sulfide, which is a gas. Now, let's see how I came up with this formula for zinc chloride. Zinc, it's Zn2 plus from the periodic table, Cl1 minus, you crisscross Zn1, Cl2. Always make sure you do that. Don't just invent formulas for compounds. So, the first sign that a reaction took place is the production of gas. The second sign that a reaction took place is the formation of a precipitate or something solid that falls down in a beaker. So you mix two things, two solutions that look like water, and all of a sudden there's something that forms. It makes a solution kind of blurry, and something solid will just precipitate or fall down at the bottom of the beaker. So whenever you take a look at an equation like this, a chemical equation, and they ask you, predict the products and tell us if a reaction took place, we have to refer to the solubility table, solubility rules table, to see if your products are aqueous or solid. If they are insoluble, they are solid. If they are soluble, so this is how we read this table. Any compound containing these polyatomic anions, or monoatomic in this case, will be soluble, but there are some exceptions. For instance, anything that has NO3 minus and nitrate will be soluble, and there are no exceptions. But anything that contains SO4 2 minus will be soluble except for strontium, barium, and so on. So if SO4 is bound to any of these cations, this compound will be insoluble. Now if you look at the bottom, these anions, monatomic or polyatomic anions, are insoluble. So anything that contains these will be insoluble except for some exceptions. So if you have, for example, sulfur with calcium, this will be a soluble compound, because anything with sulfur will be insoluble, but there are exceptions. Okay? So let's attempt this, let's use this knowledge to attempt this question here. Predict the products of these reactions. Now we have PbNO3 plus Ki. Now we know we're going to exchange the cations first. So let's do it in black. We're going to, okay, or green. We're going to basically exchange the cations. Let's write down the products. So Pb is going to go with I. So Pb is usually 2 plus, and I is 1 minus. So we're going to crisscross and come up with PbI2. And we don't know what it is, solid or aqueous. We're going to leave it like this for now, and we're going to write down the second product. So the NO3 is going to go with the K. So potassium nitrate. So K is plus 1, NO3 is minus 1, so you crisscross 1, 1. Now let's verify to see whether this compound is insoluble or soluble. Let's take a look. So it's PbI2. Let's see. So this anion, iodine, is a soluble anion except when it is bound to mercury or silver, and I forget the name of this one in English. It's coming to me in French, plomb. So whenever it's bound to Pb, it will be insoluble. And because of that, we're going to write an S here since this is insoluble. And KNO3, anything with NO3, as you see here, NO3 is a soluble anion. Anything bound to it with no exceptions will be soluble, which means we can write AQ here. Now, did a solid form in this reaction? Yes. That means this reaction did take place. Let's try again. So we have iron chloride. So is this iron 2 or iron 3? Well, it's iron 3 since the iron gave the chlorine a 3. So let's write that down here for now for our information. So iron 3 is going to go and bind to the sulfate. So iron is 3 plus. Sulfate is SO4 2 minus. We're going to crisscross. This is going to form iron 2 SO4 3 plus NaCl. And I'm not really worried about balancing reactions right now. We're just checking with the solubility rules. Let's see if iron sulfate is soluble or insoluble. So we're going to go up here, and we're going to find sulfate. So here's our sulfate, and sulfate is a soluble anion except when it's bound to these cations. And our element or our compound has an iron. Is there iron? No. No. So this is iron is not one of the exceptions, which means that we can write aqueous here. This is a soluble compound. Sodium, we're going to find a chlorine. So chlorine or chloride is a soluble anion except for when it's bound to these 3 cations. Is sodium one of them? It is not, which means that this is a soluble compound, and you already know this. When you dissolve salt in water, it's going to dissolve. It doesn't just stay at the bottom. Did a reaction take place here? No. No reaction here due to the fact that there is no formation of gas or precipitate. So no reaction. Everything is just still dissolved. A third example. Sodium nitrate, magnesium sulfate. Now we're going to exchange the cations. So sodium is going to go with the sulfate. Sodium is 1 plus, sulfate is 2 minus. So the sulfate gave the sodium a 2, and the sodium gave the sulfate a 1, which we're not going to write. So sodium sulfate plus, we're going to put the magnesium with the nitrate. So Mg is 2 plus, nitrate is NO3 minus. So the Mg is going to give the NO3 a 2. Let's find out whether these products are soluble or insoluble. So sodium sulfate. So here's our sulfate. Sulfate is soluble. Is sodium one of the exceptions? It is not, which means that this compound is soluble and is aqueous. Now, magnesium nitrate. Nitrate is a soluble anion, and there are no exceptions. It is always, always soluble, no matter what it binds to. So, this is aqueous, and there was no solid form during the course of this reaction. So, did the reaction actually take place? No, it did not. You can write products if you want, but they're all just dissolved in solution. Nothing happens. Let's take a look at this example. Barium nitrate plus magnesium sulfate. So we're going to exchange them. Barium, which is 2 plus, is going to go with sulfate. So barium sulfate. Since they're both 2, we don't get to write anything. And magnesium is going to go with nitrate. Magnesium is 2, nitrate is 1. And I'm going to put a 2 here. Oh, magnesium nitrate, we discovered earlier, is soluble, so aqueous, we work in half. Now barium sulfate, let's take a look. So sulfates are always soluble except for when they are bound to these cations. Is barium one of them? Yes, it is, which means that even though this is a sulfate, due to the fact that there was a barium bound to it, it is insoluble and it is a solid. Now, this reaction did form a solid, which means a reaction did take place. So here we had a reaction, and here we have a reaction. So, just to recap, how can we tell if a reaction took place? The first sign is the formation of a gas, which is bubbles in solution. The second sign is the formation of a precipitate, something that falls out, that's a solid that just falls to the bottom of the beaker. And the third sign is the formation of water, which is not very obvious, but whenever you react an acid and a base together, you know that water is going to form because this is a neutralization reaction. So let's take a look at an example here. So water formation happens during the course of a neutralization reaction in which we react an acid and a base to form a salt and water. Keeping that in mind, let's take a look at these examples. We're going to predict the products of these two reactions. So here we have perchloric acid, and this is your acid, reacting with calcium hydroxide. Anything hydroxide is base. What is that going to form? Let's do the same thing. Let's exchange the cations. I'll make a big arrow here. Now, the chlorate is going to get the calcium now. So the calcium is going to go with the chloride. Ca2 plus, ClO4. Chloride is 1 minus. We're going to crisscross, and we're going to get calcium 1, chlorate, ClO4, 2. So this is your calcium chlorate plus H is going to go with OH. And we write this down as H2O. So I'm going to leave it like this for now, but for the next one I'll write H2O. So H goes with OH, and we have the formation of liquid water. I am not balancing the reactions for now because I don't want to make this video too long, but normally when you do a question like this, you have to balance the reaction. Maybe we'll balance the next one. So let's do this one. Sulfuric acid, excuse me, plus sodium hydroxide, it's the base. Now, the sodium is going to go with the sulfate, so NaSO4. Na is 1 plus, SO4 is 2 minus, so it's going to take a 2 here. NaSO4 plus H2O, because we have an acid and a base. H goes with OH. Even though there's 2 H's here, it doesn't matter. H goes with OH, and it forms water in this way. Water is a liquid, and a reaction did take place. Okay, let's balance this. We have 1 SO4 here. We have 1 SO4 here. We have 1 sodium here. We have 2 here, so let's put a 2 here. Now let's take a look at the hydrogens. We have 1, 2, 3, 4. And here we have 2. Let's put a 2 here, and let's count the oxygens. 1, 2 here, and 1, 2 here. I'm not counting. I counted the SO4 as a 1 unit thing. Okay? So this is how we discover whether a double displacement reaction took place by the presence of 3 things, either gas, solid, or water. And again, water is not obvious as a product, but we know that whenever we react an acid and a base together, water is a product. I hope you enjoyed this video, and if you did, please subscribe, and that way you can tell me what videos you want me to post so that I can help you out with your school year, or if you're just interested in this. Bye!